The purpose of this video is to provide a brief demonstration on the process of creating a Civil 3D surface model. As we get started, the first thing we will need is the prospector view from the tool space. If this needs to be turned on, it can be accessed via the Home ribbon tab, and under the palettes we have Tool Space. Clicking on the tool space, the view is enabled, and if necessary, if you do not see Prospector as one of the tabs, Prospector may be turned on via the Prospector tab here. Once the Prospector view is shown, we now see through tool space that we have access to the drawing and its surface contents. Looking here, we find that there are no surfaces in this drawing. As we begin to create a surface, let's take note of what we have in this drawing called EG Topo. As I zoom extents, I see what appear to be Civil 3D points, and in zooming in, I do verify that they are in fact Civil 3D points. Now we could say that these Civil 3D points were imported from an ASCII point file. In order to create a surface which will be built from points, such points will need to be in a Civil 3D point group. Looking under Prospector and under Point Groups, we can see that we already have a Topo point group. The Topo point group, looking at the list below, contains all the points which we currently see in this drawing. Furthermore, out of the Topo point group, a subgroup, if you will, has been created out of some points that represent a ridge. This is the Topo Ridge point group. In this exercise, we will be paying particular attention to creating a surface from points and from break lines. Here we can now begin creating the surface model. First, we need to create a surface by going to Surfaces under Prospector, right-clicking, and choosing Create Surface. In the ensuing dialog box, we're going to choose a tin surface, which means that the surface will be built based upon triangulations of surface data points we will be specifying. Under Name, we can name the surface, and here I'm going to call it EG Topo. You can also give your surfaces descriptions, such as the date they were created. And finally, under Style, we find that when we build a Civil 3D surface model, we must choose a style which will constrain how the surface will appear in our drawing. Currently, the surface style is set to a style which will show us contours that are at 2-foot and 10-foot intervals and will apparently display as background contours, such as contours for an existing grade surface. Should we want to change this, we could simply click in this field, and choosing the ellipsis button, we have the Select Surface Style dialog. Here, we are going to stay with the same surface style that has already been selected. Upon choosing OK, looking under Prospector again, I now find that we have the EG Topo surface which we just created. Now the creation process we just took is only to create the entry for a Civil 3D surface called EG Topo. We do not have a built surface at all, nor have we defined any surface data to the EG Topo surface. So that's the next step. Upon creating a surface, we need to provide surface data. Having expanded the view underneath the EG Topo surface, we see that under Definition, we can provide things such as boundaries, break lines, contours, DEM files, drawing objects, edits, point files, and point groups to aid in defining our surface model. Again, in this example, we will be focusing on point groups and break lines. Going back to what has been previously stated, with respect to the points that are in this drawing, all the points already exist in the Topo point group. So what we find here is that in order to use Civil 3D survey points in a surface definition, such points need to be defined in a point group. Having built up the Topo point group, in order to define this point group to the surface EG Topo, we go back to Surfaces, and under the point groups of EG Topo, we can right-click, choose Add, and in the point group list, select Topo. Upon selecting OK, we can now say that the EG Topo surface has surface data. Hence, the program automatically launches into building the surface model, and we see that that surface model is now built based upon the application of the surface style that had been specified. As you might recall, the surface style was 2-foot and 10-foot contours for background purposes. In selecting the surface, I can further verify that it is in fact a Civil 3D surface by the fact that a context-sensitive ribbon now appears for a tin surface called EG Topo. As I clear my grips and deselect that surface, that ribbon goes away. Going back to the last process which we did, which was to define the point group Topo to the EG Topo surface, we see now that there is an entry of a point group within point groups for this surface. Looking in the list below, we verify here that it is in fact the Topo point group. If this point group selection was in error, or should it no longer belong to the surface, it can be simply removed from the point group definitions for this surface by right-clicking within the list and choosing Delete. Here, we have just seen how to create a surface and define a point group to it and build the surface. Next, we're going to look at how to use break lines in a surface definition. And as we get started, I will first say that the break line that we will be creating for this surface will be the break line that represents the ridge points that have been surveyed for this topographic surface. As previously mentioned, from the topo point group, the ridge points belonging within that group were extracted and created in what you could say is a sub-point group. This topo ridge point group contains just the ridge points. Here, given what I already have under point groups, I can actually use point groups to isolate the topo ridge point group. Hence, we see a series of points which represent shots on a ridge, which I now want to create as a break line definition for the surface e.g. topo. The reason why Civil 3D users might want to use break lines is in order to create surface definition which will more specifically constrain how surface triangulations will occur on a surface. What this means is that using break lines, surfaces can be built more accurately. When defined grade breaks exist on a surface and have been surveyed, it is usually a good idea to define them as break lines. In order to define the ridge points as a break line to this surface, we will actually go through the process of creating them as a feature line. To create a feature line through these points, I'm going to go to the Create Design panel under the Home ribbon, and under Feature Line, I'm going to choose Create Feature Line. Here, I'm going to simply take the defaults for the Create Feature Lines dialog, and as I hit OK, this launches me into the process of now simply specifying points or vertices of this feature line, which is essentially a 3D polyline. Now in this case, because I want to choose actual survey points to specify the vertices of the feature line I'm creating, I can go to the Civil 3D Transparent options and select the Point Object option. In using this, I can now simply select on the Civil 3D Point Object, and as I select on them, note that the feature line command will prompt the user for the elevation of each vertex that it is about to set. Because I have used the Point Object Transparent option, the elevations of the points themselves are actually being read, so I can simply hit Return to accept such elevations. So here, I'm simply going to go through and pick this series of points to define this feature line, which will ultimately become a break line definition for the e.g. topo surface. Now to see the effects of what a break line can do, I'm going to change the e.g. topo's surface display so that we can see how the triangulations have currently been calculated. To do so, I'm going to select the surface, and with my right mouse button shortcut, choose Surface Properties. In choosing Surface Properties, under Information, I can go to Surface Style and choose the appropriate style that I want to change the surface display to. In this case, I'm going to choose Contours and Triangles, which will retain my contours that I'm currently looking at, but also add in the triangles so that I can see the triangulations as they have been calculated. After choosing OK, I can now see the triangulations in addition to the contours. So for this example, again, we are using feature lines to be defined as break lines for the surface, e.g. topo, in order to create a more accurate surface model. We can see that this is in fact necessary because looking at the triangulations, I can see a ridge point here and a ridge point here. And this being the case, there should be a triangulation line which connects the two in order to model that ridge and get the effect that the grades within this vicinity would be sheeting away from this ridge. Here, since we have not yet defined the ridge as a break line, we can see that the triangulations are incorrect and that they are crossing the ridge. Note what happens now to these triangulations and the contours when we finally define the feature line built from the ridge as an e.g. topo break line. To define this feature line as an e.g. topo break line, again we do this through Prospector, under e.g. topo, Definition, and Break Lines. With the right mouse button shortcut, we can choose Add. Here I'm going to simply name it Ridge, and note that in defining break lines, weeding factors and supplementing factors to the break line vertices can actually be added. By not choosing either of these options, I'm simply telling the program to use the feature line and its vertices as is. Upon choosing OK, I can now choose the break line. And again, note what the addition of this break line information will do to the triangulations in this area. As I hit Enter, the surface is dynamically rebuilt. The tin lines in this vicinity are now forced through the ridge, and I see that the contours reflect the fact that off of the ridge, grades are now falling to the north and to the south. Having demonstrated the changes to the tin lines, I can now change the surface display back to simply contours. Again, this is done by going to the surface properties and choosing the appropriate style. To clean up the view of this topographic surface, I am now going to bring back all the points from the topo point group via my point group settings. And so at last, having started with points, we have created a Civil 3D surface model which has used these points via point groups and also via the addition of a surface break line defined from a Civil 3D feature line. This concludes this video on how to simply create a Civil 3D surface from the surface definition options of point groups and break lines. Thank you.